this three-dimensional problem, and we're actually going to do it in two different ways. First, let's just look at the way the textbook does it. I have some thoughts here on the side that I'm going to bring up, and we'll go through it like that. The first thing you do is read through the whole thing. They tell you about this height of 12 meters. They say that's the foot of the building. And they say that these two people, Desmond and Cella, are a distance away. They stand some distance away from the building AB that it's a height of 12 meters. Okay. Now, the angle of elevation from D to the top of the building A is 40 degrees, on one side and 45 degrees on the other side. Now, the question is calculate the distance between Desmond and calculate the distance between Desmond, there's Desmond at D, and Cella at C. Well, you got to understand, what are we trying to do? Well, I just kind of said it, but you go read through it all and go, we're trying to figure out how far Desmond is from Cella. There we go. AB, that we're trying to figure out how far that distance is there. They're asking for the distance DC, right? But now I'm thinking about this. If I could find BC and I could find BD, I'd have two sides and an angle in between, and I could use the cos rule, and then I could get at CD. So my problem is, how can I get BC? Oh, but that's going straight up. That's 90 degrees. There's two 90-degree triangles, one to Cella and one to Desmond. So that's what you're doing, and that's what you do. And when we look at the answer right here, we can go that 12 over BC equals the tangent of 45 degrees. And then they just trade places, and BC equals 12 divided by the tan of 45. That's 12. And then 12 over the other side, BD, 12 over BD is the tangent of 40 degrees. The tangent opposite over adjacent, the tangent of 40 degrees. They trade places. You put it in your calculator and you get BD is 14.3. Now it's just the cos rule. You square those two values, subtract it by 2 times them multiplied together, times the cosine of the angle in between. You put it in your calculator and you get 12.31 meters. And so in this right-angled triangle, it's just SOHCAHTOA. I was using tangent equals opposite over adjacent. I was making a fraction and solving for that unknown side. And that's how I got BC and BD. Well, there's one way to do it. Mr. Audrey's got another way to do it, and we're going to try it in the next slide.